It was a dark and stormy night. It really, really was. Knock on my front door, I open it, a salesman stands there. Can I come in, he says. You look kind of haggard, all wet. I didn't know what he was selling. I said, okay, come on in. Can we sit down in your kitchen? Sure thing. Sit down in my kitchen. He looks over at my water tap, and he says, sir, tell me, is this what you drink? I said, yeah, that's what we drink. We even give it to the dog. And at this point, he looks at me with this puzzled expression, and he says, gee, do you know that there are chemicals in your water? Well, I thought this was maybe a bit too soon to suggest, boy, that you knock on the wrong door, because I could sniff something delicious coming out of this one. So I said, do you mean the H2O molecules? He says, no, that's not what I mean. I mean the hidden chemicals in your water. Can I get a glass of water from your tap? Sure, go ahead. He digs into his briefcase, he takes out this contraption, sticks a couple of electrodes into the water, passes a current through there, and within about 30 seconds, you see this crust forming. A minute later, it's absolutely horrific. Picks up the glass, has me look into it, says, sir, this is what you were drinking. Well, of course, by this time, I knew exactly what was going on here. I had just witnessed the experiment in electrolysis. I knew this was just iron hydroxide, and I knew the scum had not come from the water, it had come from the iron electrode. But I still wanted to see where this was going. So then he digs into his briefcase again, and he takes out this water filter, and he passes a glass of water from the tap through the filter, and then we go through the same experiment. He shoves in his electrodes. Nothing happens. Sign on the dotted line, $250 for this magical device that removes the chemicals from the water. Well, at this point, I thought maybe we need a little chemical demo. So I said, okay, let me just take a few grains of salt and put it into your glass of water. And then we put back the electrodes. And of course, the same thing happens. Because what is going on here is that the filter actually was a pretty good filter. It removed the ionic strength of the water. And in order for water to conduct electricity, you have to have some ions in there. Well, when you have electrolysis, you get some of the iron electrode dissolving as iron hydroxide. Anyway, he was looking at me still puzzled. He didn't understand what was going on. So I thought we needed another demo. So I picked up this glass of water, and I drank it. And he looked at me with an expression that looked like what I had just drank. And he couldn't believe that I was so foolhardy as to do this. But of course, I knew that all I was doing was giving myself an iron supplement. So the fact is that what we were looking at here was a simple experiment. I said, you remember in high school doing this experiment we called electrolysis, where you took this contraption and we put water in it, and there was an iron electrode, another metal electrode, and you passed the current through it. No, he didn't remember anything about this. Well, many of you, of course, hopefully will remember that experiment. And when you do have an iron electrode, the oxygen that forms, electrolysis, you break water down into hydrogen and oxygen, the oxygen will react with the iron electrode and you get iron hydroxide. That's the rust. It doesn't happen if you don't have any ions dissolved in the water, because you need the ions to carry the electric current. And then I shocked him once more, because I bought the filter. Not because of his demo, of course, but because I was looking for a filter to take out some of the chlorine from the water anyway. So he was kind of happy, but of course very, very puzzled. He didn't really understand what had just happened, because of course to him the shtick made sense, didn't it? He didn't know any science. It made sense. With the filter, it doesn't happen. Without the filter, it does. And then the real finale to the story, as I watched, he walks out to his car, opens his trunk, puts in his briefcase, and leans back against the car, reaches into his pocket, and takes out a smoke. Not realizing that the chemicals in there are, of course, far worse than anything that you would find in the water. Well, this is a neat little scheme, and of course, there's nothing wrong with buying that filter. But when this is used to defraud people, that's a totally different story. These Ionic Footpaths, I'm sure that you've heard of, it's exactly the same chemistry. And of course, they're talking about curing serious diseases. You put your feet in there, and you have an iron electrode, aluminum electrode, exactly the same experiment. And of course, you get the color. Depending on just how much you're sweating, how many ions you're putting into the water, you'll get different colors, and they will tell you what kind of illness you have. $600–700 is what this costs. And we've done experiments with this, and I speak to the people after, and believe me, about 30–40% of the time, they will tell you how much better they feel. Of course, that's the classic placebo effect. But this kind of scam is everywhere. Kangen water is sold to people who suffer from cancer, and they are told that you have to drink alkaline water to cure the disease. $3,500 for this machine that produces alkaline water. Now, of course, this is total nonsense. You cannot change the pH of your bloodstream by drinking water. And if alkaline water is what you want, a spoonful of baking soda will do it, and that will be a lot less than $3,500. So this is a scam. And the problem is that these things happen because people don't have a background in chemistry. And in general, chemistry frightens people. They think that chemists are evil people just waiting to put some new cancer-causing additive into the food supply. They think that we chemists are a different breed altogether because they go to the bookstore and read The Body Toxic, and they think that chemistry is the work of the devil. Whereas I kind of think chemistry should be in the limelight. The fact is that there are no good or bad chemicals. There are only safe or dangerous ways to use them. Chemicals are not to be feared or worshipped. They are to be understood. But they're not. This is a brochure I got in my mailbox for underwear. It's actually pretty good underwear. Polypropylene, it has a wicking effect. But take a look at this. H2O, also known as sweat, is attracted to thermoskins like ants to a picnic. Our constant comfort process separates the H2 from the O, making evaporation take place much faster. Now, let's, for a moment, deal with the graphic artist here who thinks there's a covalent bond between the hydrogens in H2O. But also, this is remarkable underwear because as the water passes through it, it gets broken down into hydrogen and oxygen. It is performing electrolysis. Now, hydrogen, of course, is a fuel. It burns. You remember the Hindenburg? You remember the Challenger disaster? Well, of course, all that's happening here is evaporation, nothing to do with breaking down the water. But if this really happened, this would be magical underwear indeed. This would solve our problem with energy, if all you had to do was rub your underwear to produce hydrogen. Well, there might be a bit of hydrogen in the underwear, but it's not coming from rubbing. In any case, these are the kind of things that our office at McGill deals with. We try to cast light into the dark shadows of the world of pseudoscience, and we do this without any conflict of interest. When we first started this venture, I thought we needed a logo, and I suggested this one to the university. No, it's not that we're against eating meat. What we're against is this commodity, which is being piled higher and deeper. It's everywhere. You go to your local health food store, and you can buy some aerobic oxygen. I'm not sure where you go to buy anaerobic oxygen, but you buy the aerobic variety here, and they tell you put a few drops of this into a glass of water, drink it, you can live forever. What you have in here is a bit of potassium chlorate that will actually release a tiny amount of inconsequential oxygen. And obviously, we breathe through our lungs, not through our gut. But they will tell you that due to pollution, the oxygen content of the atmosphere is decreasing, and therefore we have to supplement ourselves with oxygen. That's the modus operandi here. But what is really amazing is that on the shelf just above or below this, you will find the antioxidants. So, and of course, they don't see the irony here. But, you know, to the gullible public, you can sell anything, including dehydrated water. The fact is that the quacks are getting bigger and better at what they do. It's harder and harder to deal with them. It's harder and harder to overturn their cockamamie ideas. Well, my whole adventure started way back in 1980. When the city of Montreal tried to keep the spirit of Expo 67 going under the guise of Man and His World exhibit, and UNESCO had a pavilion there. And we were asked to mount sort of a mini science museum. And we did that. We hired students to carry out, usual color changes, puffs and bangs, etc. We put through about 250,000 people during the summer, including these guests. And some of you may recognize him. That's Justin Trudeau, the prime minister-to-be, who was entertained by our experiments. And he grew up to become the prime minister, of course, because he had seen our experiments. And he does not think that climate change is a hoax. He does, however, believe in building a fence. He wants to do that between Canada and the US because there are just too many Americans escaping Trump trying to come into Canada. So we need a fence. Anyway, one of the demos that we did was polyurethane. Some of you may have seen this. It's a neat demo. You pour together two solutions and you get this foam. And this foam can be used to make all kinds of interesting things. And this was the time when Miss Piggy was at the height of her fame. And I was explaining that, she was really made of polyurethane. I know that's disappointing to some people, but this is her anatomy. But we were doing this at the same time that the public was worried about urea formaldehyde, which was a resin that was put into walls to basically act as insulation. And when it wasn't properly applied, formaldehyde would leach out, and that, of course, is a concern. Formaldehyde is a carcinogen. And there already were lawsuits underway about this poisonous foam, as some were calling it. And I remember very well one Monday morning, picking up my Montreal Gazette, and on page 3, the city column, there was a headline about chemistry. So, of course, I pay attention to this. And the writer was saying that while the world was worried about urea formaldehyde, here were these chemists trying to put a positive spin on a dangerous material. Well, by 9 o'clock that morning, I had a letter on his desk, together with a polyurethane egg I made with a string on it that he was to hang around his neck for penance, for having laid this scientific egg, for having confused urea formaldehyde with polyurethane. And I also gave him an analogy. I said, look, you can have 2 glasses of clear liquid, and one might be water, the other vodka. You couldn't tell just by looking. Being a reporter, he related to this. And then he did something that reporters very seldom do. He wrote a mea culpa article. He said that the real problem wasn't urea formaldehyde or polyurethane. The real problem was he had skipped too many chemistry classes in high school. And he didn't realize that 2 things could look the same, but be chemically very different. I thought I had won this battle, thought that would be it. The next day, I get a call from radio station CJD in Montreal, asking if I would like to come on the air to talk about this controversy. Okay, there was no controversy here, so I told the story like I told it to you. And then pretty soon, they asked if I would like to come on a weekly basis to answer questions from the public on science. Being young and innocent then, I said, sure. That was 1980. Of course, the only reason that you know that is because you see the dial telephone in the picture. There'd be no other changes. And I don't remember the first question I was asked. I certainly remember the second one. It was this fascinating query. You start to have juxtaposition of strange anatomy. And it turned out that the caller had spoken very quickly and had left out a key word, and that was golf. Because he was worried that sometimes golfers will pick up their golf ball and kiss it before putting it back down and whacking it for superstitious reasons, and he was worried about pesticide contamination, sort of a legitimate concern. I sang to him the anthem of toxicology, that only the dose makes the poison, etc., which I've done thousands of times since then. Anyway, that's how it all began. The show airs every Sunday, 3 to 4. You can catch it on the web. It's live. You can get the podcast if you go to our website. It is the longest running radio show on chemistry in the history of the world. Of course, it is, whoa. It is the only chemistry show. But I can cherry pick data with the best of them. So the questions keep coming. What is the safest way to burn a laminated picture? Well, a little exploration. It turned out that there had been a divorce. And the lady was scientifically minded, and she knew that this laminated picture could release some formaldehyde when it was thrown into the fire. Legitimate concern. So I said, listen, I don't think there would be enough formaldehyde, but just to be sure, why don't you hang on to this picture instead and just dispose of it at next toxic waste collection in your neighborhood? And she thought, that's a really good idea, because he really was toxic waste. Someone called me and said they saw the movie The Help, and the classic scene when she makes a pie, and what's in it. And anyway, someone wanted to know whether or not this, you could survive this. So I said, yeah, you probably could. I mean, unless there's some strange pathogen in there, it's probably okay. But I said, don't try it on yourself. There are far better people to whom you could serve this kind of thing. You get all kinds of interesting questions. This lady wondered about her kids' earphones and earbuds. Why? Because of California's bizarre Proposition 65. Of course, they have the warning on there that it could cause cancer. This is total nonsense, of course, and people have to be enlightened about this. And just last week, I get a call from a bird lover, and her problem was that the birds were not liking the sunflowers that she just bought. So she asked me, can you analyze it to tell me what's wrong? Now, the reason I mention this is just to show you how out of touch people are with chemistry. To find something, to analyze some unknown mixture is an unbelievable amount of work. So I said, yeah, we could give this a shot, but it would be at least $10,000. So she didn't think her birds were that worthy. Also, I get a call from a gentleman who wants to know, how do you get rid of the goat smell in a house? Don't ask, but he had rented his house, and the people raised goats in there. So I said, there is a way actually to do this. What you have to do is rent an ozone generator, because ozone gas will oxidize all of these compounds, and that was pretty successful. And that is a legitimate way to use ozone gas. What the naturopaths do, introducing ozone gas through the rear portals of a patient, is not a legitimate form of therapy. Over the years, we've also carried out a bunch of investigations, which I think are pretty interesting. My friend was healed by Mr. Coleman. I'm thinking of going to see him. Should I? How many of you know of Coleman? Gee, I'm surprised by that, because he's a fantastic healer. And he will tell you his story of how one day he was in the desert when he was in the Israeli army, and there was a vision up on top of a mountain, and all of a sudden he realized that he had this power. When he came down from the mountain, and one of his fellow soldiers had a painful knee, and he put his hand on the knee, and the pain resolved. And a career began. And he has been going around healing people, essentially with this therapeutic touch. And of course, there are all kinds of testimonials about how well this works. So I sent my assistant to try this out. And she went and complained of all kinds of problems, and lies down on a bed, and he just hovers his hands above. And she comes back to me and she says, I felt it. So what are you talking about? What did you feel? He says, I felt this electricity coming out of his hands. Well, this became interesting. So I wanted to check this out. So I said, oh God, how on earth did they do this? And God responded. He told me, go and check out electric touch in a magic store. Of course, I ordered it right away. It cost $300, and there it is. What do you do with it? You strap it onto your leg, and that gives you amazing abilities. It produces static electricity so that you can hover your hands over tissue paper, for example, and pick up the paper. It's really quite an impressive thing. And it's especially impressive when you hover your hands over someone and they will feel the hair stand up. Very impressive. I know because I had it done to me. So after my assistant came back, I made an appointment with him, and I go. And sure enough, it happens. And I approached him and I said, you know, I work at McGill University, and we're very interested in these things. And we'd like to, you know more about this. Would you be willing to come down and let us test you to see just how this works? So he says, of course, I'm happy to do that. So I said, okay, but we're not going to ask much of you. You come down and we'll give you a test. I'll just ask you to take off your shoes. That was a mistake. I shouldn't have said that, because that meant he caught on to the fact that I knew what was going on. Anyway, it never happened. He never came down to McGill, but he never came back to Montreal again. We've also looked at the zero-point energy wand. I think many of you probably are familiar with this. This is a miraculous device that, of course, has all kinds of abilities. It will cure every disease known to mankind. It looks like a pen without any writing point in it. So I didn't know what it was, and I thought, gee, could he have something in there, something that generates electricity or some radioactive material? So I went to a dentist friend, and we x-rayed it. And there it is. There's nothing in there except a little crack. It's just a solid piece of metal. But of course, you get all kinds of testimonials. $300 is what we had to invest to do this. But now I am in possession of this miracle. And I've been healing people with it ever since. Two ladies come to me back from Poland, where they had found out that PMAT was the cure for everything. It's a piece of cloth with these red dots on it. And here are all the things that it will do. And it comes with literature. The literature is very impressive, tell you about the electromagnetic fields, etc. What do you do with PMAT? You put it under your sheet, and you sleep on it. Now, I do a monthly lecture series to seniors in Montreal at a local library. We've got about 150 people coming every month. So I thought this was a good group to do this experiment with. So gave them the PMAT, but of course it had to be done in a blinded fashion. So we actually had it sewn into a cotton bag. And curiously, the company that manufactures it did that for us. They did it. So we had both active PMATs and inactive PMATs, ones without the red dots. And we had people fill out questionnaires about how well they had slept and how active they were at night. And I can tell you, I mean, these people are all over 60. There was a remarkable amount of nighttime activity to which they admitted. Anyway, it turned out, of course, that the ones that had used the active PMAT and the inactive one had exactly the same results. And the two ladies who actually came to me with this, who wanted to sell it, we showed them the data, and they decided that they were not going to go into this fraudulent business. So the questions keep coming. Is tripolyphosphate a chemical? Well, of course, as soon as I hear this, I know where we're going with this. I know where we're going, because what they're really asking is this toxic or is it poisonous? Because chemicals are made by terrible people in laboratories. She had actually been looking at the list of ingredients in a cleaning agent, and she saw sodium tripolyphosphate. She didn't know what it was. It was multisyllabic. It would frighten the food babe to death. And so she wanted to know, what this was. So I explained. This was indeed a very interesting chemical. It had the ability of tying up the minerals in the water, which would enhance the activity of the detergent. So she was kind of satisfied with that, because if you expect chemicals somewhere, it's in cleaning agents. That's where they belong. 2 weeks later, she calls me back, trembling voice. She had once again crossed swords with sodium tripolyphosphate, but this time it was on a food. And some of you may recognize this food. It has many versions, but it is Kraft Dinner. So she says to me, I feed my son Kraft Dinner every day, which apparently was not a problem. what is a cleaning agent doing in there? So I said, this is really a multi-talented chemical because here is performing a different function. What it is doing here is enhancing water absorption by the starch so that when your son clamors for his daily allotment of Kraft Dinner, you can deliver it much more quickly. I'm not sure she bought it this time. Why? Because chemicals don't belong in food. They're okay in cleaning agents. And I think she had conjured up some kind of image that the Kraft company, knowing that this was a messy thing to eat, had found some way to clean the kid from the inside out. Where do they get such info? From books like this, Food Additives by Ruth Winter. This lady has no business writing such a book. How do I dare make such a potentially libelous statement? Well, when I say this in Canada, I usually say because we're not in the US, but we are. The reason I can say it, because I would say that the chance that she's in this crowd is pretty slim. And second, of course, I can back it up scientifically. Because if my phosphate-fearing friend looked up in this book and found phosphate, yeah, bubble baths, cuticle softener, cleaning agent, that all makes sense, right? But also in incendiary bombs. Well, yes, a fundamental error. Phosphorus is used in incendiary bombs. Phosphate is a completely different thing. A most elementary chemistry student would, of course, know this. And not only incendiary bombs and tracer bullets. So now she would not only imagine her son bursting into flames, but disappearing without a trace. So obviously, a lack of understanding of the chemistry leads to a lot of confusion. The fact is, obviously, that we live in a world of chemicals. There are 60 million recognized in chemical abstracts. 99.9% of these are naturally occurring, but those are not the ones that get the press. It's the synthetic ones that are looked on as evil entities. We, of course, are chemical entities as well. We release a lot of chemicals from our body, over 3,000. There are thousands of chemical reactions going on in our body all the time that constitute life. But to people, chemicals are in flasks in the laboratory, need to be locked away. The fact is that our food, our drugs, our cosmetics, we ourselves are made of chemicals. Some of them, of course, are potentially toxic, but it is only the dose that makes the poison, as Paracelsus told us 500 years ago, the cornerstone of toxicology. And of course, the presence of a chemical does not equate to the presence of a risk. It depends on the context. It depends on the amount. The bottom line is that life is full of risks. No matter what we do, there are risks involved. Terrible risks. Horrific things can happen. Oh, don't go, oh, we're nice people, we faked it. They are, but you know what? They are not the innocent little creatures you think they are. Because everything in life has risks and benefits. And it's a question of weighing the risks versus the benefits. And that's what we dedicate ourselves to. That's why we organize every year the Trottier Public Science Symposium, invite noted speakers from around the world, some of whom, of course, are here. Joe Nickel is here, Kevin Folta is here, David Gorski is here, Harriet Hall is here. We've had them at our symposium, and we get a lot of people. Last week, we had 700 people for Patch Adams. Most of you, of course, would not like what he said, but he was sort of very interesting. We do this every year. And of course, one wonders, is there any result? Does any of this matter? Are we reaching anyone? Well, I think we are. And the reason I think we are is because I made it into the National Enquirer. And if the National Enquirer tells you that you don't have to worry about chemicals, then I think people are going to listen. But you gather that chemistry, I think, is absolutely fascinating adventure. It's been a great path to frolic through. There are, of course, questions that arise, and we do not claim to have all of the answers, because there are some questions that no matter what, there will never be an answer to. But we do try, and if you want to follow our work, mcgill.ca/OSS. We, of course, do Facebook, as everyone must, and we tweet, and we write books. My latest one, Monkeys, Myths, and Molecules, is here. And I appreciate you listening to me. And I know that we're preaching to the choir, but maybe the choir picks up a few little snippets that you can go and sing to the others out there. Thanks very much.